Hello friends, welcome to Learner's Planet. This is Alka Maheshwari. Friends, with this session, I am going to start a series of sessions of number system. In the very first session, we are going to discuss the types of numbers. Friends, in this series, we'll be discussing a good number of points, important definitions regarding number systems, and many more. Okay, let's begin the journey of the number system. The very important point that I'm going to mention over here is this topic is actually very important in the case of maybe you are going to take CAT examination, maybe other MB entrance examinations, maybe ZAT, maybe any bank probationary officer examinations. So just see the every topic very carefully. Just try to understand the things. Revise the lectures until you are clear with the concepts. So let's begin the journey. First, let's discuss what types of number systems are there. Friends, there are various types of number systems. Here we can see binary number system. What binary number system is? In this system, only two numbers are there, 0 and 1s. Since there are only two numbers, that's why we call it as a binary number system. Similarly, with base 3, in this system, there are only three numbers, that is 0, 1 and 2. Since three numbers are there, this number system is known as the number system with base 3. Similarly, in our day-to-day mathematics, we use decimal number system. In this system, there are 10 numbers which are 0, 1, 2, 3, 4, 5, 6, 8, 7, 8 and 9. Since there are 10 numbers in this system, we call it as a decimal number system. And friends, already I have told you, in our day-to-day mathematics, we use this system only. Now we see the various definitions. Let's begin with what a digit is. Each of the 10 familiar symbols, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is known as a digit. A numbers can be represented by the digits only. Okay friends. Now let's see the terms face value and place value. Face value of a digit in a number is the value of the digit itself, whatever it may be. The face value of a digit remains same whether it is at the units place or hundreds place or any other place in the number. Here we see the example of 540. The face value of digit 4 is 4. Though in this example 4 is at the tens place, but the face value of 4 will be 4 only. Yes, but the 4 is at the tens place, so the place value, here we introduce the term as place value. The place value of 4 in this case will be 40 since it is at the tens place. So let's take one more example. Suppose I have 5, 8, 9, 2. In this example 2 is at the units place, so its place value is unit. Face value will be 2 only. Similarly, if we take the example of 9, the face value of 9 will be 9 only, but the place value will be 90 since it is at the tens place. Similarly, in the case of 8, the face value will remain same, it will be 8 only, but since 8 is lying on hundreds place, its place value will be 800. Similarly, in the case of 5, the face value of 5 will remain same, it will be 5 only, but the place value will be 5000 since it is at thousands place. Okay friends. Now let's see various types of number. The very first number we are going to discuss is the natural numbers. What are the natural numbers now? The numbers which we are going to use for counting, are known as natural numbers. In our day-to-day life, whenever we are counting anything, any object, maybe any person, we use natural numbers only. Suppose I wish to count number of children in a class. I'll be telling 10 children, 14 children, 50 students. something like that. I won't be saying 0 students. I won't be saying -5 students. What I'll be saying is a positive number, a positive whole number. So we use natural numbers in our day-to-day counting. The set of natural numbers is generally denoted by capital N, and set of natural numbers begins with 1. We also tell is it a positive integer set. What integer is, we'll be discussing just now. Now, it's what a whole number is. Natural numbers including 0 are called whole numbers. The set of whole numbers is denoted by capital W. So what is the set of whole numbers? The set of whole numbers is all the natural numbers plus there is an extra element, that is 0. So all the natural numbers plus 0 is known as the set of whole numbers. We also call it a non-negative integers. We also call it a set of non-negative integers. Okay friends. Now what are odd numbers and even numbers? The numbers ending with 1, 3, 5, 7 or 9 are called as odd numbers, and the numbers ending with 2, 4, 6, 8 or 0 are known as even numbers. Friends, we have to keep one thing in mind, that odd and even is a breakup of natural numbers only. Negatives are known as even or odd integers. We cannot say them even or odd numbers. Okay friends? Now let's see what integers are. The numbers, maybe I have taken example over here, it's -3, -2, -1. These are called integers and the set is denoted by I or Z. Okay, now what is precisely an integer is? What is the set of integer is? Friends, we have discussed about natural numbers, we have discussed about whole numbers. So all the natural numbers are also included in the set of integers, and these are known as positive integers. That means the set of natural numbers is known as positive integers, and 0 is neither negative nor positive integer, and the remaining numbers, that is negatives, are known as negative integers. So precisely there are three types of integer: negative integers, positive integers and 0. Okay friends, or in other words we can say natural numbers is the subset of integers, even whole numbers is the subset of integers. I just quickly revise the definition of integers. Precisely negatives of natural numbers, natural numbers themselves, as well as 0. All these three make the set of integers. Now let's discuss what are the prime numbers. Let we have a number p, that's a natural number. This p is said to be prime if it has exactly two distinct factors. Two distinct factors, that means the number 1 and the number itself. Suppose I am having 2. I'll be having two factors of 2 only, that is 1 and 2 itself. Similarly, I'll be having two factors of 3 only, that is 1 and 3. So these sort of numbers are called as prime numbers. That means the numbers which are having exactly two factors and the factors should be distinct. Okay friends, so if we are going to calculate the prime numbers between 1 and 100, 1 to 100, these are 2, 3, 5, and you can see this sequence. In all there are 25 prime numbers. So precisely there are 4 one-digit prime number, that is 2, 3, 5 and 7, and 21 two-digit prime number. Okay, friends. So sometimes this question is asked in various competitive exams. So we should be quick with the answer that there are only 4 one-digit prime numbers and 21 two-digit prime numbers. Sometimes we are even asked about the applications of the same also. That we'll be discussing when we are going to discuss the MCQ multiple choice questions in our coming sessions. Okay, friends. Friends, sometimes we have to check whether the given number is prime or not. And the numbers, if they are so big, we just cannot calculate manually whether the given number is prime or not. So we just apply a method which I am going to describe over here. Just see the method carefully. Suppose x is a given number and k is an integer that is very near to the square root of x. Then if x is not divisible by any prime number less than k, then x is prime. Otherwise, it is not a prime number. Suppose I am having an example of 269 over here, whether I have to check whether it is a prime number or not. Right? So I just take a number whose square is closer to 269. So I just have 17 whose square is 289. Square of 17 is 289. Fine. So I just have to check the numbers below 17 if they are factors of 269 or not. Okay. So I am having the numbers which are prime and less than 17, that is 2, 3, 5, 7, 11 and 13. In the session of divisibility test, we have already seen the divisibility test of all these numbers. So quickly we just can apply the divisibility test and will come to know whether 269 is divisible by any of these numbers or not. Since it is not an even number, it won't be divisible by 2. Since the sum of digits is not divisible by 3, which is 2 only, so it won't be divisible by 3. Similarly, in the case of 5, 7, 11 and 13, this number is not divisible by any one of them. Hence, it will be a prime number. Suppose I take an example of say 231. So let's check whether this number is prime or not. So around 231 we get a square of 15, that is 225. 15 square is 225. So now let's check with the prime numbers below 15, that is all these numbers will be, that is 2, 3, 5, 7, 11 and 13, all of them are below 15. So let's check with them. So it's not an even, so it won't be divisible by 2. But yes, it will be divisible by 3 since the sum of digits, that is 2 plus 1, it is 3 and it's 3. So the number 231 is divisible by 3. So it's not a prime number. Similarly, you can check for the bigger numbers. Friends, we have discussed prime numbers. Now we discuss what are composite numbers. Suppose we are given a number, that is a, then a is said to be composite if it has at least 3 distinct factors. 3 distinct factors means, suppose I am having a number as 6. So what are the factors of 6? Let me write. It is 1, 2, 3 and 6. And all the four, there are 4 factors of 6 and all the 4s are distinct from each other. So 6 will be known as composite number. Okay, friends. So similarly, a number will be either composite or prime. Prime number we have already discussed. We have an exception for this statement, that is number 1. 1 is actually neither prime nor composite. Okay, and in the sequence of prime numbers, we have already seen there are 25 prime numbers from 1 to 100, and there are 4 prime numbers which are having single digits. So, and we might have observed that you might have observed that there is only one even prime number, that is 2. So in the entire sequence of prime number, that is, there is single even prime number. And we have already discussed that the number will be either prime or composite. Exception to this statement is number 1 only, and 4 is the smallest composite number. 4 is the smallest composite number. That means 4 is the number which is the smallest number and it is having 3 factors at least. What are these? So it's 1, 2 and 4. Okay friends, now let's discuss what are co-prime numbers. Two natural numbers, maybe they are prime or not, are co-prime if their HCF is 1. What HCF is? Their highest common factor is 1. Let's take the example. It's 1 and 2. 1 and 2 are co-prime to each other. 1 and 3 are co-prime to each other. 3 and 4 are co-prime to each other. In this case, 4 is not prime, but the combination of 3 and 4, but the set 3 and 4, the set of 3 and 4 will be definitely co-prime. So similarly, 3 and 10, they are also co-prime to each other. Similarly, 5 and 6, 7 and 8. Friends, we have discussed that the co-prime numbers should have their HCF as 1. 7 and 8. Suppose I am going to factorize 7. What are the factors of 7? That is 1 and 7. What are the factors of 8? That is 1, 2, 4 and 8. What we observe over here is there is only one common factor of 7 and 8, that is 1. So precisely the definition of co-prime numbers is the natural numbers are co-prime if their HCF, that is highest common factor, is 1. Okay friends, I hope you must be cleared about co-prime numbers. Two distinct prime numbers are always co-prime, that it's obvious since there won't be any common factors except 1 between them. And consecutive numbers are always co-prime. Here we see 5, 6, 7, 8, 3, 4, maybe any other combination 15, 16. Definitely these combinations will be co-prime numbers. Now we see what are twin prime numbers. If the difference between two prime numbers is 2, then these are called as twin prime numbers. So it's 3, 5, 5, 7, 11, 13, 17, 19, 29, 31. Maybe other examples are there. So 3 is also prime over here, 5 is also prime over here, and the difference between these two prime is 2 only. So these are known as twin prime numbers. Friends, we have discussed about natural numbers, whole numbers, integers and their bifurcations. Now, we see what rational numbers are. All the numbers which can be represented in the form of P by Q are known as rational numbers. P by Q, that means a number can be represented as a fraction, where P and Q are integers and denominator, that is Q, should not be 0. Okay, let's take one example. Now we see here 4. 4 will be a rational number because it can be written as 8 by 2. So all the numbers are rational numbers which can be written as P by Q form. Now if these sort of numbers are rational numbers, then what are the numbers which are non-rational? That these numbers are called irrational numbers. We'll be discussing irrational numbers later on in this session. Suppose I take one example. Here 3.3333 and the series goes on. Now whether this number will be rational or irrational. So friends, just observe the definition carefully, just see the definition carefully. The decimal part of a rational number are either finite or recurring. Here we see the decimal part is not finite but it is recurring. So it's 3.3333 and the series goes on. So what it will be? Can it be represented as a P by Q form or not? If it can be represented as P by Q form, then definitely it will be a rational number, otherwise it will be an irrational numbers. So I just give you a clue, that is 10 by 3. What 10 by 3 is? 3.333333, so on. So 10 by 3 is definitely a rational number because it can be written as P by Q. It is already written in P by Q form. Now we see what are irrational numbers. Friends, the numbers which are not rational are known as irrational numbers. That means the numbers which cannot be written in P by Q form. Okay, so what are, let us take some examples of the same. Here I see root 2. Root 2 will be 1.414 and the series will go on. Similarly, 1 plus root 3. We cannot write them as P by Q form. That means which number should be divided by one particular number, so will be then only the number can be written as P by Q form. So in this case we cannot find the P and the Q. Okay friends. Now friends, let's see what are irrational numbers. Irrational numbers are real numbers which cannot be expressed in P by Q form. We have already discussed about rational numbers. Rational numbers can be expressed in P by Q form, but these numbers cannot be expressed as P by Q form. So we call them irrational numbers. Let's take example of irrational numbers. Here we see root 2. It's an irrational number. 1 plus root 3. It is an irrational number. E, that is exponential. That is also irrational number. And a special example of irrational numbers is pi. We generally use the approximate value of pi, that is 22 by 7. But actually the value of pi is an irrational value, so pi is an irrational number. Friends, we see the value of root 2 is 1.4142135562 and so on. We have already discussed the definition of rational numbers. What we discussed over there, either the decimal should be recurring or terminating. But in this case, the digits after decimals are neither repeating nor terminating. Okay, we see here 414. There is no proper sequence is there. So root 2 is an irrational number. Friends, exponent, that is E, is now the approximate value of E is actually 2.71 and it is known as Napier's constant, and the approximate value of pi is 3.14, or we have already discussed that it is 22 by 7, but it is actually approximate value of pi, but the pi is actually irrational number. So, and we can see more examples over here. All these numbers are non-terminating and non-repeating decimal numbers. So all of these are examples of irrational numbers. Now let's understand the definition more clearly, more precisely. A number root a, that is square root of a, is an irrational number if a is positive and a is not the square of a rational number. That means we will not accept negatives under a square root. So the number should be positive, this a should be positive, and a should not be a perfect square. If a is not a perfect square, then root a will be an irrational number. Suppose I take root 4. Root 4 is actually 2, or we can say it is positive negative 2. So root 4 is not an irrational number, but yes, root 2 will be an irrational number because 2 is not a perfect square. Similarly, the negatives of square roots, that is negative of root 3, negative of root 5 by 3, will also be irrational numbers, and these are known as negative irrational numbers. But in any case, will not accept the negatives in square root. That means this terminology is not acceptable if a is positive. Okay friends. Similarly, a number nth root of a is also an irrational number if a is positive and not a perfect nth power of a rational number. Suppose I take cube root of maybe 5. So cube root of 5 will also be an irrational number. It should be kept in mind that pi is an irrational number that we have already discussed, and 22 by 7 is a rational number because we take an approximate value of pi as 22 by 7. Okay friends, I hope you must be cleared about rational numbers and irrational numbers. So in our next session, we'll be discussing more types of numbers. I hope you might have enjoyed the session. Just revise the session and learn all the terminologies, all the types of numbers, so you'll be better cleared in the next sessions. All the best.